phone app. Okay, so I typed in Arduino examples into Google, and I found Arduino tutorials, which is where I want to go. So I go into tutorials, and then there's these built-in examples, right? So this is going to go with all the code that's built in here. So how I get the code in the IDE is I just go into File and Examples and then pull up the thing I'm looking for. But there's a little more to it than that. So let me show you the first kind of easy one here. Let's make the Arduino make a light blink, right? So this is the thing that's different between processing and Arduino work, is there's this hardware required thing, right? Which means I have to actually have some objects to get this to work. The first thing I need is an Arduino board, right? Duh. And then I need an LED. It's an LED.
Laser emitting diode.
Laser emitting diode.
It's light.
I've been lied to my whole life.
Pretty sure it's light emitting diode, but let's look. I'm really the past and past participle of wet.
We both lose.
Light emitting diode.
Okay. I like laser diode.
I like laser emitting diode better too. It's just too bad that it's not true. Okay, at any rate, I need an Arduino and a laser a laser maker. And apparently a 220 ohm resistor, whatever the heck that is. So I threw in Google 220 ohm resistor, and I'm seeing one that's got like 3 reddish bands on it.
It doesn't matter that much.
Yeah, and thankfully for this one, it doesn't really matter that much. It should be noted that if you use the wrong resistors for things, you can sometimes let the magic smoke out of stuff.
That'll leave the resistors really small, though.
Yeah, if you use a resistor that's way too small for something that, yeah, whatever. I would try to find the right resistor if you can, but yeah, honestly, hardware is cheap. I'd probably settle for any resistor some of the time. Okay, so I'm going to need to find a resistor and an LED and an Arduino, and then, okay, so what is this business about? You see all this thing? This is just kind of an explanation of what we're going to do in this example, right? And then here's a whole bunch of pin things. What's this pin business about?
Stuff that goes into the board.
Yeah, this is something about which little contact on the board you're going to turn on and off to make the blinking happen. You guys cool with that? This one's actually about which one is the LED that's built onto the board versus the LED that we're going to plug into the board. And then down in here, there's like, okay, so if you want to do this, blah, blah, blah. And then what the heck is this thing?
It's like voltage goes through resistor, then LED, and back into board.
Okay, looking at this looks like the Pixies,
Yeah, hold on.
because we don't talk about voltage in here. The Pixies,
Forgive me. Forgive me.
the Pixies look like they need to come out of pin 13 on this board and prance their way through the resistor, which what?
Slows it down.
Slows down the conga line of Pixies, right? And then they go through the LED and do whatever they do with the LED, which makes it light up, right? And then they return to ground. You guys see that? So that's that conga line looping. Okay, so down here's a, this is a what? What do you guys call this thing?
Blueprint.
Yeah.
Yeah, this is a circuit diagram or a circuit schematic. This thing is just a picture of what you want to make, right? You guys with me on this? Okay. And then there's the code, and the code is already built into the IDE, right? So really, I'm just going to open the one that's in the IDE, and then we'll kind of force this to work. Cool? Okay, so in the Arduino IDE, I went into File, Examples, Basics, and then I opened Blink, right? So I have Blink open here. And there's a cool thing I just learned about multi-line comments. You guys see that? Instead of commenting out each line, they did this thing, where they had a /* and then a */.
Magic!
Cool, I learned a new thing. One thing I might try, since Arduino's IDE is based on processing, I might go try that in processing and see if it works. Gabe swears it doesn't. He says you need a star on every line. Ben thinks he's crazy. I don't care. But we could try it, right? Like, it would be an interesting concept to try.
I guess that works with Java, but like processing is built off of Java, so I don't know why they'd add that you have to have a star on everyone.
Yeah, that seems counterintuitive to block commenting, but whatever. It should be noted that that thing actually works in LaTeX. That exact same thing works in LaTeX. Okay, so then what do I have running here? Like, what does this sketch do? Because there's not actually that much of it, right? So there's a setup method, right? And what does the setup method have in it? Just one thing, right? What's that one thing doing? Yeah, that's saying, look. Right? Pin mode says, look, pins. What we're going to do is that built-in LED pin, right, is going to be in mode output. Right? What that means is I'm going to be able to put some stuff at that pin. I'm going to be able to turn that pin on and off. I'm not going to check what's on it. I'm going to turn it on and off. You guys see that? If I wanted to check what was on it, what would I put?
Input.
Probably input. Right? And that would let me check whether that pin was on or off. As opposed to me turning that pin on or off. You guys see that? Like if I wanted to register whether the LED was on or off, I'd want it in input mode. You guys see that? Okay. And then down here in our loop, right, we're doing digital write to the LED built-in high. What's that probably going to do?
When it registers high, when high voltage.
Yeah, so that's going to flip the voltage to high, right? That's going to actually turn the volts to 5 volts, right, on that pin, as opposed to low, which would be 0. Except when it's not. Some of these boards, or some of these pins, will have the high and low reversed, right? You might need to check that. In this case, I only care if it's blinking, right? So I'm going to turn it to high for a while, and then I'm going to turn it to low, and it doesn't matter whether I'm turning it off, and then on, or on, and then off. But the effect is going to be exactly the same. You guys with me on that? And then what's this delay thing doing?
Delays it by whatever minutes.
Yeah, because otherwise, if I just flip it to high and then flip it right back to low, are you going to be able to see? Yeah, you might not even see it turn on and off because your eyes only refresh at about 70 or 80 times a second. Like with your guys' young eyes, my slightly older eyes are probably down to 60. Your grandparents' eyes are probably down to 50. And then what's this other guy doing?
Turn blinks off and then delays it again.
Delaying again, right? Okay, so let's check our code. Compile. Boop. Things work fine. And then we upload. And and of course the the video can't see that at all, but it is blinking.
Blinking video. What is it? Don't listen to it. It's lying.
Okay. Well, stories, cognitive dissonance aside, it is blinking. Okay, so I shortened the delay, right? And then I uploaded this, and now it's blinking really fast, right? And it should be noted that if I close the IDE, right? Like, no, I don't want to save the changes to Blink. I just want to be done. This thing is still blinking.
You can unplug it and plug it back in. It'll still blink.
Okay, and if I unplug it, it'll stop blinking. Why is it not blinking right now?
There's no pixies.
There are no pixies moving. The pixies are all just chilling in their line. Or they all died. I don't know. Forget it. But then if you just plug this into anything that has power, right? It's going to start blinking again, even though I didn't tell it to. Because it still has the code on it, and that's what it's going to do. It's just going to keep looping through the loop chunk, regardless of what's going on. Okay, so this is nice for things like your remote weather station, right? Like, you don't want to go down there and tell it to work every once in a while. You just want it anytime there's power, it should do its thing. Even if the battery dies, and then the light hits it later, right, and charges it up again, it should just start doing its thing as soon as it has the opportunity. Cool. So these are nice for that, like, remote, like, I don't want to go over there and touch this thing ever. I don't care if the batteries run dry. I just want it to keep doing its thing anytime it can. Cool. As opposed to using, if we wrote this digitally on here instead of actually onto the processor, then it might have this, if the battery runs out, it might forget what it was doing. Right? I have a very dumb light at my house that has a digital switch in it, which means that it keeps track in the software of whether the light's supposed to be on or off. And that means that when the battery runs dry in the middle of the night, it forgets to turn on again the next time it gets dark. The Arduino will not do that. Right? Anytime it has power, it'll do its thing.